Professor Kim Nelson with the Jewelry Design Department at the Fashion Institute of Technology in a series of tutorials for JD 138 Basic Rhino. Continuing with our ear dangle project, our filigree piece. Here we have the piece completed up through the filigree wires. The wires have been interwoven. I'm going to go ahead and complete this piece. First thing I'm going to want to do is to develop the bezel and the frame. We have this in another tutorial, so I will go about this in a very direct way to get it complete. I will repeat the commands so you can at least know what I'm doing as I do it, but I'll move at a good pace. I'm going to extrude an inner wall of the bezel up 0.8 of a millimeter. I'm going to do a extrude to point from that curve down to the end of my culet. I'm going to do a cutting plane so I can cut that stone seat that we're making basically 1/3 of the way down the pavilion. Trim that off. Going to do a straight extrusion from this bottom edge. Going to bring that down -0.7. Going to join these pieces together. Going to cap this top surface, do a planar surface. I'm only doing that so that I can assign a C-plane to it. Going to project this outer rim to that C-plane and do another extrusion straight down, grabbing the quad or end of this geometry so they're the same length. I can delete that curve now. Gonna go ahead and make another planar surface from this outer rim. Trim that planar surface away using the poly surface in the center. Gonna join these pieces together. Gonna cap planar holes on the solid menu. Gonna fillet the edge 0.25. Bring back my curves. I'm going to take the two curves for my rim, my frame. I'm going to project those to the C-plane as well. Going to extrude those once again with a solid option down to grab either the quad or end of that piece. I can delete those curves, turn the rest of the curves off. I'm going to fillet both edges of this 0.38 millimeters. And I finished those two components. I'm going to leave the wires in location where they are, but I'm going to move the other geometry into a position where I find it more suitable for the design. You can use gumball if you want. I prefer just to go into a C-plane that allows me that vertical movement. I want to move it up enough so that the edge of this surface, this fillet, is clear of the top of the wires. I want to move the stone and the bezel together as a unit farther up still so they break free. Check that in an orthographic view, see if I think that's right. I'm going to lose a lot of that bezel thickness, maybe down a little bit. That might be a touch too high. That's fine. That's a good place to start. I'll see whether I keep those in those positions or not as I progress. I want to trim my wires back a little bit. They're extending as they are now well beyond the frame, and they're cutting far into the bezel all the way through the bezel, so I don't want that. I'm going to go ahead and offset a curve 1/4 of a millimeter out, because I still want these to penetrate into this wall, but I only want them to go in 1/4 of a millimeter. Same here. Want them to go in the wall, but only 1/4 of a millimeter. Going to extrude these two, both sides, so they make a nice cutter. Make them tall enough that they cut through the wires. Check the direction on them. Remember, you want them to point towards what you want to keep. We're going to do a Boolean difference to cut. I want them to point towards the wires. So those are good now. My wires need to be Boolean together into a solid piece. Select all of my wires. Solid union. And then solid difference. I'll pull it off the menu here this time. Want to remove from that surface, and I want to cut with this and this. I'm going to bring back my drawing. Now I want to create a control surface that I can modify, dome up these wires. I want that surface to go well beyond the edge of the wires, so the wires are completely contained on top of that surface. To achieve that, I'm going to offset 1/2 millimeter. Twice as far as I did last time. And that gives me 1/4 of a millimeter leeway for that surface. It's important to me that the seam, I want it here at the bottom, so I'm going to double check these and see if the seam is where I want it. Curve, edit tools, adjust close curve seam. It is not where I want it. So I'll grab them one at a time and pull them around. Make sure I'm snapping to the curves and not some geometry on the wires. Going to now put a cross section. I'm going to be using a bi-rail sweep to create this flow surface. So go to my surface tools, bi-rail sweep right here. Select first rail, select second rail, select cross section. And there I have it. Not really enough points in this structure to do what I want to do. There are no points in the middle to allow me to form this up. It's going to be too rigid and unflexible, so I'm going to rebuild it. That's an F5 shortcut. If you didn't have the shortcut, you could have gotten it off of right here, rebuild. That's rebuild edges. Right here, rebuild surface. Okay, but I'm just going to push F5. F5 works just as well for curves as it does surface. I want 36 points going around. I want 7 going across. 3 and 3 is fine for the curvature. Gonna hit OK. There we go. Going to go ahead and turn on the points, but not before I do that, I need to make a copy of this surface. I'm going to do it externally in that I'm going to Control-C, copy to clipboard, Control-V, paste from clipboard, use grid snap to move this to one side. Put these on a different colored layer. I want to grab my surfaces, my pipes, and move them over here in preparation for the next step. The next step, I'm going to flow these wires from this surface onto this one. Okay? I'm going to make sure I record history when I do so. Then I will be able to adjust this surface, and as I adjust this surface, the flowed pipes will update automatically to whatever form I create. So I'm going to pick my pipes. Record history is on. Flow along surface. It's important you pick in the same location. I picked just to the right of the seam, So over here I will also pick just to the right of the scene. Now the computer I'm working on is a 32-bit system from 2009, so it will be slow. So in the interest of accelerating the tutorial, I will go ahead and pause the recording and resume after the flow has taken place. There we go. Okay. So now I can come over here, turn on the points, and I can adjust these points however I would like. I want to be able to select these points in rows as they go all the way around. And Rhino surfaces are laid out with an X and a Y orientation. This is done randomly, so you don't really know which way is which when you first start out. A couple of ways you can find out, but really the simplest is just to experiment. I'm going to go to Select, going to go Lasso Points, going to pop that flyout out by pressing on the triangle. And what we're looking for is these two. Select U, select V. I've got these 3 points selected. Now if I select the proper one, it'll select all 3 rows around the outside of the surface. If I get the wrong one, it'll just select this row of points. I'm going to try select U, and that worked just fine. Once again, I'm going to go into a C-plane that allows a vertical movement. I'm going to move. Now, as I pointed out in class, there's more than one way I can do this. I'll do this a different direction than I did in class. I'm actually going to just pick the outer row, move it first. Make sure grid snap is turned off. And I'm just going to move it down visually a distance that I like. There will be a delay in the response of the software. Okay. And if I undo that, you will see how the ends of the wires go back up. And unfortunately, I'm going to pause and come back for a second. Okay, what had happened before is after I hit Control Z to show you the wires unbent, I hit Control V, which pasted other geometry in. I wanted Control Y to redo. So you can see how those wires move back and forth based on what the surface did. Okay, going to now add a second row. Hold down Shift key, select one point from the next row, hit Select U, and I'm going to move both rows of points down. You'll see the computer goes back into deep thought, and I will go ahead from here. Okay, so I have, you can see the wires curving to follow. Okay. In class I did a simple dome. I'm going to do something a little more interesting. Here I'm going to go ahead and select this inside rim. I'm going to move these up, get kind of an S-curve going. Once again, Rhino is in thought. Please be aware at home that the tutorial, they're going to go faster because I'm pausing and then resuming. If your machine takes a while to do each one of these, don't panic. So does mine. Okay? Okay. So you can see how that has started to lift the inside rim. I'll undo it so you can see how the wires drop. And go back up. Going to do the same thing with the second row. Grab my second row of points. Now, is that my second row of points? You want to make sure, because if you look, you'll see that it isn't. There's a bend here. The actual second row of points is not here. It's at the end of this dotted line. It's right there. Select of these up. Okay. Okay. And you can see that is bringing up the ends of those pipes. I want to grab now the center row, and I want to move it up. Okay, that's raised the center up. I'll undo and redo so you can see the difference. I want to lift this row up a little bit as well, and I want these two rows to go up a little higher than they have. Okay. You do not have to do, in fact you probably shouldn't do with your piece what I'm doing with mine. The idea is to explore and to figure this out for yourself. See what you want to do. Be creative with it. It is your design, it's your piece. Okay. That's enough bending for my piece. You may want to do more or less in yours. I'm going to turn off the control points. To E-map. Sorry, I was having some fun with layers there. I'm going to E-map the wires just so that the difference in densities of isoparms between the two is not so obvious. So you can see on the flat form, flat wires, the surface passes directly through the center, and on the forms that have been formed up, the surface passes through them as well. Okay, not quite as precisely, although actually yes, because actually you can see this much of this is below the surface here, and this much is here. You know, because they're woven up and down, so they aren't all on dead center line. The wires aren't. So that's the next step for your piece. Then I want you to assemble your piece. Okay. Wires are going to stay still. I want to evaluate whether everything still works the way I wanted it to. And yes, this is still a good length here. These have not come so far up the side that they're causing an issue for my setting. Okay. What I need to do now is I need to crop the back of my setting. I don't want a really heavy setting, and this is quite thick right now. I can tell that just without the fillet involved, just the surface itself, I can measure that length. I can find the seam, or if I'm in a hurry, I can just grab an isocurve, change the direction to V by hitting V, enter, measure the length. So it's 1.547 without the cap on top. I know the cap on top is 0.38, so it's almost 2 millimeters thick. I would like it to be as thin as it can be. It doesn't even matter on an earring if the culet of the stone comes out the back. It's not a big issue because it's just going to be hanging in midair. So make a decision as to whether I think I would like to thin that out, and I think I would. So I'm going to go into either front or right C-plane so I can get a cutting plane perpendicular to my surface. Click anywhere, pull off to one side with the ortho. What I want to do is get this to where it's pretty much the same height as my setting, as my mounting, my piece. And then I'm going to move it down the distance I want. I would like this to be about 1.2, 1.5. Let's take 1.5. So I'm going to pick a point to move from, constrain the distance, 1.5. Hold the Shift key. And that will give me the depth of my frame at 1.5. Okay? I don't want a really heavy frame. If I cut it there, some of the are going to actually pass through it a little bit. I have to decide if I like that or not. I can either move my wire a little bit so they don't hang out the back a touch. Let's see how much I would have to move them. That did it. Is that still okay here? Yes, I'm still there. So I'm going to do that. I'm wondering if I want my culet to hang that far out the back. I'm also wondering if I wouldn't like to have more elevation. That stone, remember this bezel is going to be pushed down, and that stone, really the table of the stone is going to be the top of my piece. I wouldn't mind having a little more elevation here. So I'm going to give it a little more oomph for my piece. You're designing your piece. You will decide what's good for you. I think that's fine. That's fine. You will want to measure to your setter, mention to your setter when they're setting the piece, that the culet does come out the back. Otherwise, they might put this on a bench and try and push down and ship your stone. So that is worth considering. They would have to put it in pitch or something. If we want to avoid that, maybe we want to avoid that. But if I want to avoid that, I have to have a fairly thick piece, or a fairly jewelry, the realities of jewelry. I'll move this up a little bit more. Move this down a little bit more. Cleared my culet. Okay. That works for me. So I'm going to trim off the back of my frame. Solid difference. Select you want to subtract from. Oh, did I check my direction on this? Let me make sure. Oh, need to flip it so it points towards what I want to keep. Boolean difference. I've done that. Okay. Now, it doesn't matter to me, of course, that this comes through at this point. That's no difference at all. What I am wondering is if I like the square flat bottom of it, or if I want this to kind of form along with the wires. I could do that if I wanted to. I could make it have a soft shape instead of that flat bottom. Let me show you how I would do that if you want to do that with your piece. Okay? First off, I would make a copy of this and paste. Then I would put a planar surface on top. I want to do a blend surface between these two so it's soft. Fastest way to do that is going to be to grab that ISO curve here. You actually can get that off the curve menu as well. I'll just keep this out. I want it to go in the other direction right now. It's going in V, and V is not what I want, so I'll type in U. It's either U or V, one of the two. I'm going to let this come down a ways. Okay. And I'm going to use it to trim the top of that surface away. I'm going to do an offset curve, sorry. I'm going to grab the edge of this. Let it come in a ways, and use that to trim off the edge of this. Now I'll do a blend surface between the two. See if I like what the rhinos come up with. That's fine. And I will join these together. Keeping a C-plane active. I mean, usually I go back to top, but I'm going to keep that front C-plane active. By the way, my fallback on C-plane when I want to move vertically is front. I usually go top, front, top, front. I use right C-plane less often. There's no reason for that except for I just find it handy that I use the same two C-planes repeatedly. I orient my drawing. I'm used to looking at it that way, my piece. So that's why I keep going front if I want to move up and down instead of right. It's just a habit I've developed. I recommend you develop a similar habit. Pick front or right as your favorite C-plane for vertical movement or adjustment, and then use that consistently. It'll make your modeling easier. I'm going to bring back the piece, if I can find it. Here we go. Here are the wires. I want to use this as a cutter for the bottom of this. This could be a good place to use a gumball. You can see it's passing through the wires now. If it doesn't at least pass the corner of that surface, there's no point in doing it. I want to cut that flatness off. And I can actually carry it. There are two considerations here if I'm going to do this. One consideration is that I don't go so far that I am above the wires. It has to stop at least where that wire is, which it does. The other consideration is this thickness on the bottom. I have 7/10 there. I know that because I engineered it in. I really don't want to go less than 5/10 for this thickness. Okay? So I'd like to know what this length is right now. It should be 7/10. Hit V to get a curve that I like. Okay. Get rid of the gumball. Measure that length. It's 7/10. I would like it to be 5/10. Okay? So I'm willing to take 2/10 of a millimeter off here to soften the bottom of it. I won't go more than 4/10 because 4/10 is the minimum I can get a nice casting from it. So here's what I'm going to do. I'm going to find out exactly where 4/10 is along here from the top edge. To do that, I want to make sure, I want to check the direction of this curve. That's what I wanted. I want to know where the beginning is. The beginning is where the arrows start from. That's the beginning. Good. I'm going to come over here on the Transform menu, tab, the point pull out. Here's a divide curve by length, divide curve by number of segments. We use the number of segments in making our round diamond. If we left click, we get by length. It asks, it says the curve is 0.7. Enter the length of segments you want. I want 0.4. That'll put 1 point right here. Okay? And that tells me this is 4/10. If it had been 8/10 long, there'd be a second point down here. I can use that point as a gauge. I know I don't want to go below that point or above above that point in this case. I'm not going to use the gumball because it's not very precise. I'm going to stick with my front C-plane and do M enter. I'm going to pull this so that it's holding my, I want to make sure I'm holding down ortho as I move. And I want to cut away that point, but I don't want to lose, so I want to get rid of the corner of this, and I want to stay within the 4/10. And I did it. That should work. Let's see if it works. There's a tangency here between the corner of this and this. They're very close. Rhino might fail that Boolean difference. Check my direction. That's good. At this point, I'm going to copy all these components. Control C, copy to clipboard, Control V, paste. I'm going to group them, Control G. I'm going to change them to this storage layer because I'm going to start cutting and working with things. Don't want to lose my originals. So, do a Boolean difference, see if it'll work for me. It might fail because those are so close, that corner and that surface. It worked. Okay. It's a subtle thing, but it is kind of nice that this has kind of a dished out form that follows along with the surface that the curves were made from. You do not have to do this with your piece, but I wanted to show you how it was done because it gave you a chance to see several tools. How to round that surface using trim tools, how to measure this and make sure we had a precision fit. So exercise to do the exercise, and then decide if you want to keep that as part of your piece. So I'm almost done. Bring back my stone. Okay. Only thing I have left to do now is the jump ring. Go ahead and put these on a storage layer. Whenever I put things on a storage layer, I group them first. That way they're easy to select as a badge, and then I can ungroup them later. Okay, to make the jump ring, I'm going to go into the right C-plane. This is a situation where the right C-plane is exactly what I need. I'm going to go to the curve tools. I'm going to draw a circle, centered, radius. Use grid snap to get the center of circle. I want the diameter to be 3 millimeters, as per the directive on our assignment. It's a 7/10 pipe or wire, so I'm going to offset at 0.35, half of that 7/10. I can throw away the first curve, do a solid pipe. I want the radius for that. Let's make it a diameter. Make the diameter for that 0.7. I can delete the curve in the middle. And now I'll move this into position. I want it to bite in, okay? I want it to be about halfway up the frame. But what I don't want is I don't want to see it bite in up here. So what I need to do is I need to back that off and respect where this curve begins. I want it not to bite in much above that. But I have to have a good solid union, a chunk of metal going in, so that the casting will flow properly. So I'm, once again, this is real jewelry. I am deciding between what I want aesthetically and what I need structurally. That's about what I need. I can cheat maybe a little tiny bit, but not more than that. So it's not going to be absolutely perfect. I don't get everything I want. You rarely do. But I can come very, very close. Okay? That is my completed ear dangle. Now I'm going to do solid union to join the whole thing together, to combine it into one solid piece. Solid union. Jump ring and frame. Solid union, frame, and wires. Solid union, frame, bezel. this. Take a look at it in EMAP to evaluate how it looks as a finished piece. It's nice. Look at it in polished silver by going to Sunset Room 2. It's a nice little piece. Okay. If you wanted to print this, the next step would be to take this mounting, this piece, and export it. You would go to File, Export Selected. That way it will only export the part that you've selected. It won't export the stone. It won't export any of your other layers. It's only going to export that one part that you selected. You would pick where you want it to go. Okay. And you would change the type from Rhino 5 to STL, stereolithography. That's the standard output for 3D printing. And you would hit save. Accept Rhino's defaults. Accept Rhino's defaults again. Binary export open objects is how you should do it. File successfully written. This is not going to look different here, but if we want to go in and open that file, we can. We'll only see Rhino models unless we come down this list and ask to see STLs. There it is. Send to the printer. Okay, so that's it for this video. Thanks for watching.